Okay, so for this problem it says men's heights are normally distributed with a mean of 70.1, standard deviation 2.8, and women's heights are normally distributed with a mean of 63.4 and a standard deviation 2.5. The standard doorway is 80 inches. Okay, part A. What percentage of men are too tall to fit through a standard doorway without bending, and what percentage of women are too tall to fit through a standard doorway without bending? Let's look at part A first. Okay, so I always draw these out. Let me move this a little bit so you can see it. Okay, so I've done the men here on the top half of this. So we have 70.1, and we want to know what percentage of men will fit in this 80, right? Without stooping. So we're looking for this area right here. And similarly for women. Not drawn to scale, just kind of using these models to help me think about this. I'm looking for this percentage right here. Let's use StatCrunch to do this. So within the question help and StatCrunch. So I'm going to go Stat, Calculators, and select Normal. So let's do the men first. Got the mean here of 70.1, standard deviation of 2.8, and we want to know less than 80. In fact, it says, I read it again, it says what percentage of men are too tall to fit through the door. So with too tall, we're looking for greater than. There we go. So it's 0.0002. It already has it in percent, so we're going to shift that decimal point 2 places. So it is right here. I'm going to move it over here and then one more. So 0.02%. So that should have been the answer on that one, 0.02%. Now let's do the women. So the women, the mean was 63.4, standard deviation of 2.5. And again, we're looking for how many women are going to be taller than 80. Very small, so basically 0. This is 1.5684 times 10 to the negative 11. So that, remember, that scientific notation tells me I'm going to move that decimal point 11 places to the left because it's to the negative 11. I'm basically dividing by 10 11 times. Divide by 10. Each time we divide by 10, that decimal point just shifts over to the left one place. So that one is essentially 0. Okay, for part B, it asks, if a statistician designs a house so that all the doorways have heights that are sufficiently for all men except the tallest 5%, what doorway height should be used? So let's flip back over here. I'm going to draw my picture. Every time, I'm pretty good at these, and I still draw these pictures out. So I'm looking for this value right here. I don't know what that value is. I do know this value here is 0.05, right? The tallest 5%. I don't mind if a few people are going to have to stoop, right? So what is this value? Let's flip over to StatCrunch. Okay, so I've got the mean of 70.1, standard deviation of 2.8, because we're just looking at the men here, and it's we want this probability to be less than 0.05. So let's change this to less than. Or actually greater than, right? So my shading doesn't look right? So what am I thinking about here? Flip it around. I need this value to be over here. So really what this thing's going to give me is I need to make this 0.95. So there's that 74.7. So the way it's shading, it's giving me this value here to the left. So that's why I had to change that around. So sometimes you got to play with this just a little bit. So again, this area here in the white is 0.05. So this area here is 0.95. This would be very similar on the TI. Let's flip over there and see how this one is done on the TI. So on the TI, I'm going to go to second vars to access the distribution menu. This is an inverse norm. So on the previous two problems, we would just use norm CDF, but now I'm going to do inverse norm. And it's my area, which is 0.95, my mean, 70.1, standard deviation of 2.8. If you have the option here, I think it defaults to the left. So if you don't have the option, it defaults to the left, so that's why I point to 0.95, press enter. And so that's why it's important to draw this out. If you happen to not draw it out and maybe you put 0.05, you'd see that your answer doesn't make any sense. So always draw these out. And we get the same answer we did using StatCrunch. Hope that helps.